Okay, here's rationalising the denominator, some of the harder ones. Previous video we decided that we would like to change the denominators in these fractions into nice numbers, as in rational numbers rather than irrational with surds. And one trick was just to choose the surd that you see in the bottom and multiply both top and bottom by that surd. But it doesn't quite work as easily here, because if I times top and bottom by root 3, the top becomes 3 root 3, and the denominator becomes 2 root 3 minus 3. So timesing by root 3 over root 3 hasn't really achieved the goal of changing the bottom number, the denominator, into a nice number. Okay, so there has to be a slight different way of doing this, and there is. It's a trick. With the full explanation, it operates under difference of two squares. Let's give it a go. Put a bracket around here, copy exactly the numbers, but do a sign change. Whatever you do to the bottom, you have to do to the top to keep the fraction same value. So the top is 3 times by 2 plus root 3. I'm not going to expand that just yet. I'm going to concentrate on the bottom. And expanding, you might FOIL it out, or some other acronym. 2 times 2 is 4, plus 2 root 3, minus 2 root 3, minus and a plus is a minus, root 3 is 3. And then what you find is that the top is 3 into 2 plus root 3. Can you see what happens on the bottom? The plus 2 root 3 minus 2 root 3 cancels each other out, and you're left with just a nice number. In this case, it's 4 minus 3 is 1. So in fact, we don't even have a denominator, we just have something divided by 1, which we just leave as this. That makes life a little bit easier for us to work with that fraction now in this form, 3 into 2 plus root 3. You can have it in expanded form, and that would be absolutely fine. 6 plus 3 root 3. Mathematicians tend to like things factorised. Okay, so let's have a look at part B. Root 3 minus 1, so we're going to times by root 3, 1, sign change. Root 3, 1, sign change. And the mistake people might make here is that they forget that this is actually supposed to be in a bracket, and that we multiply everything there by the bracket. Okay, so we need to FOIL it out. So let's look at part B. Here I think I will expand the top just to see what might happen, if it'll simplify any. So FOIL it out. This is 3 root 3 plus 3. And this is 2 times root 3, so I'll do that in one go. 2 root 6 plus 2 root 2 times 1 is 2 root 2. And that's all divided by, well, root 3 times root 3 is 3, plus 1 root 3 minus 1 root 3, the root 3's cancel out, and then negative 1 times positive 1 is minus 1. So I think that's about it really. We've got 3 root 3 plus 3 plus 2 root 6 plus 2 root 2, and that's all divided by 2. And you can see that there's actually is there a single factor on the numerator that's got 2 in it? Well, the first term is 3 root 3, and then we've got plus 3, then we've got plus 2 root 6 plus 2 root 2, so there's no common factor here. So in fact, that is our final answer. And then part C, we've got 2 plus root 3 over 3 minus 2 root 5, and again, little bracket here, copy the denominator, 3 2 root 5, sign change, and then 3 plus 2 root 5. Okay, a little bit more complexity here, but we'll try it. Let's expand the denominator first. Again, 3 times 3 is 9, and this will be plus 3 times 2 times root 5, so that's plus 6 root 5. Then we've got minus 6 root 5. The roots cancel each other out. Then the final bit, we've got to be tricky. Negative times positive is negative. And here we've got 2 root 5 times 2 times root 5. So that'll be 2 times 2 is 4. Root 5 times root 5 is 5. So on the denominator, we've got 9 minus 20 is negative 11. On the top, we might expand it, or we might actually just leave it as it is. I'm thinking because there's root 3's in one bracket and root 5's in the other bracket, I don't think if we expand it, anything will kind of add together and simplify. If you look at part B, we had root 2's and root 3's, and nothing really simplified, it just expanded to give a big crazy number. And so we can leave it like that, or we can do one final thing here if we're being fancy, we can times the top and the bottom by -1, and that would leave a -1 lead in, so that would be 2 plus root 3 into 3 plus 2 root 5, and that will be all divided by 11. And again, mathematicians tend to like not having a negative on the denominator.